In this next example, example 4, solve the differential equation dy dx is equal to 6x squared over 2y plus cosine of y. Before we do, though, here is a preview of what this should look like. Well, of course. All right, that's a whole bunch of different solution curves depending on the value of our initial condition, as we'll see. Now, step number 1 is a separation of variables, and notice that we've got y's over here on the left, and we also have y's on the right-hand side. And then we also have some x's on the left and some x's on the right. And it looks like to separate the variables, all we will need to do is to cross multiply this. I'm going to have 2y plus the cosine of y dy should be equal to 6x squared dx. That one, extraordinarily easy to separate the variables. Now we want to take the antiderivatives of both sides of this. Antiderivative of 2y would be 2y squared over 2, which just means y squared, plus the cosine of something. Its antiderivative is the sine of something, sine, is equal to, on the right-hand side, antiderivative 6x squared would be 6x cubed over 3, and a 3 would cancel, making that 2x to the third. And then let's not forget, please, our constant integration. So I'm going to leave this one like that because this is not one where you could easily solve that thing, isolate y, because you have this sine of y that's mucking everything up. All right, let's take a look at the next one, shall we? Oh yeah, and that's what the graph looks like. Obviously, example 5, given the initial condition y of 0 is equal to 1, find the particular solution of xy dx plus e to the negative x squared times y squared minus 1 dy equals 0. All right, and unfortunately I don't have a nice graph to preview this with, or to scare you with, depending on your perspective. So let's just give this one a try after we switch it to our official blue color. All right, example 5. And our differential equation is xy dx plus e to the negative x squared y squared minus 1 dy equals 0. And then we do have our initial condition, which was y of 0 is equal to 1. Okay. All right. Step 1 is a separation. So let's just kind of notice that we have my dx is on the wrong side. I got to get this dx over to the right side of the equation. And for this case, we're just going to have to subtract that thing over. So rewriting e to the negative x squared, y squared minus 1 dy is equal to negative xy dx. All right. And then also noticing that we have y's on the wrong side of the equation. They need to meet these other y's. And then we also have our x's stuff that's on the left side that needs to meet the x stuff that's on the right side. So here we're going to do a little bit of division. We're going to divide the y over to the left side, y squared minus 1 over y dy. And then we'll divide the e to the negative x squared over to the right side. I would have negative x over e to the negative x squared dx. Now we're almost ready to take antiderivatives, but like you want to try to simplify if you can. Makes the process of antidifferentiation a little bit easier. Like for example, on the left side, y squared minus 1 over y, you don't want to take that antiderivative. But if you divide it by y and simplify to get y minus 1 over y dy, then it's much, much easier. Likewise, on the right-hand side, we have this negative exponent that's in the denominator. Well, we can move that e to the negative x squared up to the top and then make its exponent positive x squared dx. Now is a good time to take antiderivatives. All right, so separately, the antiderivative of y is y squared over 2 minus And then I have 1 over y dy is the natural log of the absolute value of y. And then it looks like on the right-hand side, we're going to have to use a u substitution. Since I'm using green for all these x's, I guess that's what I'll use. So I've got u should be equal to our x squared, and our du is equal to 2x dx. And notice that this negative sign is kinda in the wrong place. I'm just going to go ahead and bring this outside. This negative. And then I need a 2 in there, and I'll fix that with a 1/2 on the outside, and then rewrite stuff. Okay, so this negative 1/2, the green negative 1/2 gets to stay. And then on the right-hand side, the 2x and the dx become the du. And then the e to the x squared is e to the u, du. Great, so continuing to simplify, left side stays the same. And then, where'd that fraction bar go? I don't know. I'd have negative 1/2 e to the u plus c. And since I don't want to have to keep rewriting 14,000 times, I'm going to take the u out and replace it with our x squared, which are what our u was equal to. Okay. Now, I can, at this point, go ahead and stick in my initial condition, or let's go ahead and get rid of the 2's in this particular case. I'm going to get rid of the 2's by multiplying everything by 2. Maybe make it a little bit easier to work with. I'd have y squared minus this natural log term is also going to get multiplied by 2 is equal to a negative e to the x squared plus 2 times c, which is just some other constant, which I will call c. Right, and one other pro tip, and that is I'm going to take this 2 here, and I'm going to bring it in using a property of logarithms. Going to bring it on the inside, and that's going to make that y squared. Not only is it going to make it y squared, but it's also going to drop the absolute value symbols because we have just squared the y, which makes it positive again. All right, minus e to the x squared plus c. So far, so good. Now, I'm going to go ahead and use my initial condition. And my initial condition, I think, was 0, 1. Let's just verify that real quick. And plug in 1's for all of my y's. So 1 squared is 1, minus the natural log of 1 squared is equal to negative e to the 0 squared plus c. All right, that sucker is 0. E to the 0 is 1. So I shall have 1 is equal to 1, negative 1, plus c. Add the 1 to the other side, and I can see my c value is equal to 2. Lastly, let's go ahead and replace our c value. Y squared minus the natural log of y squared is equal to negative e to the x squared, or you can add that to the other side if you wanted to, is equal plus 2. There we go. And yeah, here, why don't I do that? Why don't I do that? Maybe make that plus e to the x squared. I added it to the other side. I said it was equal to c or plus c, but I need to put the 2 up in there. There we go. Now it looks real nice. Again, this is another one which would be extraordinarily difficult, if not impossible, to write that explicitly as a function of x to isolate the y. So we're just going to leave it right there and then call this video done, and we'll come back with some more experience working with some more differential equations.